Hello everyone, so today we will solve this question, count number of nice subarrays. So an array is called nice subarray if it is basically contains the k odd numbers. Okay, so k is given in the question. So see here there is a nums given and k equal to 3. So all the subarrays which has k odd, basically the 3 odd numbers. So that would be a nice array and we have to count all such arrays. So that is our motto. So let me explain what would be my approach. So basically what I am doing is, first of all I am writing one method which will give me the at most k odd numbers in an array. Okay, so I will get, with this help of this function, I will get all the subarrays which has at most k. So in this case at most k means it would be include also all those subarrays which has 1, which has 2 odd numbers, which has 3 odd numbers, which has 4 odd numbers up to k. Okay, so I will first of all get the at most k values, all the subarrays. Then what we will do is basically we can use this function to get the exact k function. So what formula we will use here is, I'll tell you. So see here, once we will find this at most k function, we can use this formula, that at most k minus 1. Okay, so this will give exactly k sized subarray. I mean the k number of odd digits having those kind of subarrays it will return us. So basically first of all we have to pay attention that how do we write the at most k function. Okay, so see here, basically we would have one variable called count k. This will basically sum up all the odd numbers. Okay, now whenever count k is going bigger than k, because we want the at most k value, so we have to basically, what we have to do is we have to update count k equal to count k minus nums start. Okay, so whatever start value it is, we will exclude that value. Okay, that also should be %1. So let me edit that also. So this would be basically the %2 only, like this. So we have to deduct this value and start we are basically increasing. Okay, then this is our answer value where we would be storing the all such subarray, means I minus start plus 1. Okay, so every time we are going in this way and finally we would have the total number of such subarrays. So let us do a dry run of it. So see here, initially start equal to 0. Okay, so we are here, so start is 0, not a problem. Count k, so count k is nums I is 0. Okay, so 0% to it is 1, so count k is initially 1. Okay, now we will go to this value. Okay, so when we will come while, this is basically less than k because k equal to 3, so we will not go in this while loop. So answer would be what? So answer value would be here, we can write I, which is 1. So 0 initially, so 0 minus 0 plus 1. So right now answer is 1. Okay, so now our I will come here at 1. So see here, count k is equal to nums I %2. This is 1. So 1 plus 1, it is equal to 2, right? So count is now 2. And again we are not going inside while loop because k equal to 3 and we have only 2 value. Now see here, we are here at answer equal to answer plus I minus start. So 1 minus 0 plus 1, so 2. So 1 plus 2. Okay, now we are going to I equal to 2 here. I increased here. So see here, count k equal to count k % nums 2. But this is nums 2 is actually 2. Okay, so this would not increase because it's 0. So count k would be still 2. Okay, so we are still not going inside while loop because k is 3 and we have 2. Now we are coming here. So 2 minus 0 plus 1. Okay, 2 minus 0 plus 1, this is 3. So answer is now plus 3. Okay, now finally we are coming at I equal to 3. See here, count k equal to count k nums I %2. So this is 1. So it will become 2 plus 1. So this is 3 now. So count k is greater than, so it is equal to k. So still we are not going inside while loop. So again we are coming here, I minus start plus 1. So 3 minus 0 plus 1. So we are making answer equal to plus 4. Okay, now we are coming here at the end of it. Now see here, So count k equal to num psi percent 2, so it would increase. So now count k bit will become 4. Okay, now come to while loop. This is 4, count k is 4 and k is 3. So we are having going to inside the while loop. So now what we have to do, count k equal to count k minus nums start. So start is 0. Okay, so 4 minus 1% 2. So this is 1. So 4 minus 1 equal to 3, right? So now we are making it 3, and see here we are coming here. So I is like 4. So 4 minus 1, because start value is now 1. So 4 minus 1 plus 1. Oh, so this would be 4 only. Okay. Now finally we are done with this, because array is done now. So sum up it, 4 and 4 8, 3 11, 11 to 13, 1 14. So total 14 subarrays are there, which having value k equal to 3 or less than 3. Okay, number of odd values. So 14 subarrays are there. So similar dry run we can do for k equal to 2 as well. Okay, so it is up to you. You guys have to do this dry run in the same way. And when we do the dry run for k equal to 2, it gives us actually 12. Okay, so here when we do the difference of these two according to this formula, this will give us 2, which is actually the answer of it. Okay, so I am leaving up to you guys that you have to do dry run for k equal to 2 and then verify it. So now I will quickly write the code of it. Okay, so same code I have written. Okay, then nothing new is just this is my for loop. These are the usual variable k count and answer. So initially my start is 0. So see here I'm just making %2. So you can see %2 it will work. So if it odd number, it would add 0 value. So we are still counting all the odds. Okay, because whenever it is odd, then only it will give 1 value. Okay, so k count here, and then we are checking if it is greater than k, we have to basically increase the count, that is start value, and we have to decrease whatever value is residing at that value with %2. And this is our subarray formula, to end minus start plus 1. So it is returning answer. So this is our Atmost k function. Now this Atmost k function I am using here because we need to find exactly those subarrays which have k exact odd numbers. So for that I am using this formula, Atmost nums k minus Atmost k minus 1. So this will give us exactly k value. So let me execute this code. So it is executed fine. Let me submit it as well. So it is working fine. Here we are not taking any extra space, though this problem also can be solved using prefix sums, and also we can solve this problem using some queue based solutions. I would highly suggest you guys should be try that as well. And if you have any comment, please make a comment over there. Thank you for watching the video.